Welcome. So the next few videos are going to be dealing with transformations using matrices, and this video we're going to be looking at linear transformations in 2D. Now we can define a transformation in 2 dimensions by describing how a general point with position vector xy is transformed. The new point then is called the image. Now, there are various transformations, but to be a linear transformation, they always map the origin onto itself. Okay, so that's an important point of distinction, I suppose. So a translation wouldn't be a linear transformation, because a translation would move an object, and that would also end up moving the origin from where it is to the new position. So that wouldn't represent a linear transformation. So if I had the transformation and we were mapping x, y, and they went to ax plus by as cx plus dy, now, that could be represented by the matrix M, the standard matrix A, B, C, D, because A, B, C, D multiplied by xy would give me ax plus by, cx plus dy. Okay, so let's have a look at this as an example with numbers. So first of all, we're looking at just finding the matrices that will represent these linear transformations. So what we're doing is we're looking for a matrix when multiplied by xy leaves me this matrix. Okay, that's basically what I'm doing. Now what I'm going to do is just rewrite this. So I'm going to put the x first on the top and the x first on the bottom, and add a 0y in. So that'll be -1, 3, 4, 0. Okay, so remember horizontal then vertical. So -x plus 3y, 4x plus 0y. Okay, so this is the matrix. This is the transformation that transforms xy into 3y minus x and 4x. Okay, I'm going to show you, we'll look at the next one. Okay, this is what's happening. So 0x minus 5y, x plus 3y. So it's 0, minus 5, 1 and 3. And again 0x minus 5y, which is that top, 1x plus 3y, which is the bottom. Okay, so this is transformation V, this is transformation T. So this one, the square S has coordinates, and there's the 4 coordinates. Find the vertices of the image of S under the transformation T. So we apply the transformation to each vertex. Okay, and it always goes in front. So this will be 1 times -1 is -1, and -2 times -1 is 2. So -1 plus 2 is 1. And we got -2 minus 1 is -3. And then I do the next one. So -1 minus 4 is -5. -2 and 2 is 0. Now, another way we could do this, kind of all in one go, would be to take my transformation and multiply it by all of the values. So -1, -1, -1, 2, 2, -1, and 2, 2. Okay, so you go in across and down. So -1 and 2 give me 1. And if I do the bottom one, -2 and -1 gives me -3. Okay, and then as I do this, I'll pick up all of those values. Okay, so instead of doing 4 separate ones, I could just do one transformation in one go. Okay, so that's one way of doing it. Now, what does this look like? Okay, so in blue here is the original square. Okay, and then the transformation is this large square in black. So you can see the transformation, what it's done is it's enlarged it, and it's also rotated it. Okay, you don't need to worry about that at the moment, just getting used to the initial part of transformations. And this is a linear transformation because obviously the origin 0, 0 is unaffected by the transformation because they're multiplying by 0, so it stays at 0, 0. Okay, so I'll just show you, in red, 1 minus 2, 2, 1 multiplied by the origin is going to be the origin. Okay, so that is fixed, so that is why it is linear transformation. Okay, so before we get stuck into some questions, if you are enjoying the video so far, smash that like button. If you're not a subscriber, subscribe to the channel. Okay, obviously it helps me out. You've watched enough YouTube channels to know that. It'll also help you find my channel again if you're finding this kind of content useful for you. Anyway, let's get on with the questions. So here are 3 questions for you to have a go at. Don't forget, the answers will be at the end of the video, and don't forget, if you want to help me out financially, hit that join button. Alright, pause the video now. So, a quick and easy way to check whether something is linear would be to use the 0, 0. So if 0, 0 is my xy, then it will go to 3 times 0, 0 plus 1. So it equals 0 and 1, therefore not linear, because it doesn't map the origin onto itself. So P is not linear. Now let's have a look at Q. It's going to 0 and 0 squared, which is 0 and 0. So it's linear, right? No, it's non-linear. I hear you say why, you ask. Well, we wouldn't do it that way. We're just looking at the x. The x going to the x squared is non-linear. Okay, so it does still map 0 to 0, but the x to the x squared isn't going to be linear. So if you put 1 in, it's going to be 1. If you put 2 in, then it's going to be 4. Then you put 3 in, it's going to be 9. It's not a linear pattern. So, you know, like when we did the square, it was linear. It still ended up as a square. But with an x squared, like this one, you could start off with a square and you wouldn't end up with a square. Okay, so that's why it's a non-linear. R, that is, yeah, that's linear, so it's 2, 5, 0, 4. Okay, so it is linear. And S, linear, and S is not linear, because 0, 0 goes to minus 1, 0. So that's why that one's non-linear. So the matrix that represents this one. So first you want to write this one in terms of x and then y. Okay, so this is just minus 3, 1, 4, 5. Okay, because if you multiply this by xy, you end up with this. And finally, triangle T as these vertices. Find the vertices of the image. So 0, 4, minus 3, 1. It's minus 2, 1, 0, 5, 4, 1. So we get 0, 4, so that's 4, 0, 20, 0, 4. And we got 6 and 1, 7, 0 and 5, 5, minus 12 and 1, minus 11. So these are my coordinates. Looks like it's probably a rotation and some sort of enlargement. And there you have it. That is the end of this video on linear transformations. Hopefully you've had just a slightly better understanding of it now. Next we're going to move on to reflections and rotations. So this is where it starts to get a little bit harder, and where some of these transformations you really need to kind of memorize them. After that we go on to enlargements and stretches, and then, you know, multiple transformations, so successive transformations, and then we'll look at some inverse linear transformations. Okay, so that's the next few videos coming up. I will, well, trying to post them kind of one a day, about 1:30 UK time. Okay, just so you're aware, it's summertime in UK. Anyway, I'll see you in the next video.